This is the video for Objective 5I. I can use the laws of exponents to simplify exponential expressions. So what we're trying to do here is eventually be able to simplify these guys on the right. But let's just write them all down here. So raising a term to the 0 power. In this case, the answer is always 1. So a to the 0 power, the answer is 1. 6 to the 0 power, the answer is 1. No matter what, the answer is 1. So we take this is just going to become 1 right here. X to the 0 power is 1. So now we have 8 times 1 is 8. And then we can't combine these or change them. All we can do is just put them next to each other. So we have 8y squared. Okay, when we're raising a term to a negative power, it just puts the number in the denominator. Goes to the denominator, becomes positive. So when something's just like this by itself, it's already in the numerator. It's like it's over 1. So what we're going to do is we're going to switch these. This is going to go to the denominator. So this becomes 1 over a, and then make sure you make your exponent positive. Okay, because a fully simplified expression, we have all positive exponents. So in this case, it's like this is over 1. It's in the numerator, so it's going to flip it and put it in the denominator. And we have 4 to the 3rd power. Does become positive, and now we can even simplify that. 4 times 4 is 16. 16 times 4 is 64. Okay, so be careful. Make sure that you're only doing it to the 1 or applying it to the letter or number that the exponent is on. So, for instance, this 3 isn't going anywhere. It's staying on top here. So if this was over 1, my 3 is going to stay on top because there's no exponent on it. My y is going to go on the denominator, and y times 1 is just 1, so you can get rid of that 1. But y to the positive 8. In this one here, the only thing that's moving is this y up here. The 2x stays there. The 3z to the 5th stays there. But this y, to make it a positive exponent, I have to move to the denominator. And we do want positive exponents. What's going to happen then if we have the negative power in the denominator? Well, it's just going to flip and go to the top. So it's going to go to the numerator and become positive. So here, it's in the denominator. So to make this positive, I need to put it on top, and I don't need the 1 underneath. This is the most simplified version right there. This 2 to the negative 5th is going to come up to the top and just be 2 to the 5th. And 2 to the power of 5 is going to simplify to 32. Okay, the only thing that's moving here is the y. It's going to come to the top, and we have x times y to the positive 3. Okay, multiplying powers with the same base. And the important word here is same base, so it has to be the same letter or same number. In that case, you're going to add the powers. So I would have our powers here are n and m, so that what would happen is I would have to add the n and the m. Okay, so on this one here, we do have the same base, 5 and 5. So we're just going to take our powers and add them. So we have 5, and then 7 plus a negative 4 is actually going to be minus 4. Plus a negative is minus. So I get 5 to the 3rd. 5 times 5 times 5 is 125. Down here, there's a negative on this. We're still adding them, even though there's negatives in there. So I have negative 3 plus 5. Negative 3 plus 5 is 2, and then 4 squared is 16. So some examples here. We can combine the 4 and 3. Notice that this term is being multiplied by this term. So 4 times 3 is 12. We can combine those just like that. And then x, well, we have same base here. That means we're going to go ahead and add those exponents. So 9 plus 5 is going to give us a power of 14. Okay, just multiply across the top and then multiply across the bottom. We're starting to get a little bit more complicated here, but we're still just going to start with the multiplying and then see where we're at, see what we can simplify. So 3 has nothing to multiply by, or there's just a 1 there, so that's still going to be 3. 3 times 1 is 3. And then our x squared and x to the 6th, I'm going to add those exponents and get 8. 2 times 4 is 8. Y, same base, so I can add my exponents, so I'm just going to do y. 5 plus a negative 2, I'm actually subtracting 2, so this is going to be y to the 3rd. Okay, so even though we had negative here, if we had moved this up, we couldn't have combined them like that, and we would have eventually combined them once they're over each other. So this was just an easier route here. It was just to multiply across and then see where we're at. So this is fully simplified and as far as we can go. Raise an exponent to a power, we're going to multiply those powers. So when we have m to the power of m, then that whole thing raised to n, this becomes a to the power of m times n. So here's a numeric version of this 3. I would multiply 2 times 3 is 6. I can simplify this further and go 3 times itself 6 times, and I get 729. Okay, so what about this? 2 raised to 9 raised to 0. Well, 9 times 0 is going to be 0. And then 2 to the power of 0 goes back to our one up here is always 1. We could have also just seen anything to 0 is going to be 1, but even when we multiply them together, we still end up with that 1 here. All right, so some problems for us to try. 4 times 5, power of 20. And then y, we have 3 times a negative 4 is going to give us negative 12. And as I said earlier in this video, we never want to have a negative exponent. So we're going to go ahead and keep simplifying this using the rules that we learned above. But we need to put this in the denominator. So this becomes 1 over y to the positive 12. Okay, raising a product to a power. Now the important thing here, you are going to distribute the power to everything, but the important thing I really, really need you to remember is it has to be product. It has to be multiplying those two together. So for instance, you don't need to write this down, but if I have x plus y squared, you cannot do x squared plus y squared. That would not be correct. Okay, so it only works when it's product, not adding or subtracting. You'll see down below it does work with dividing. So distribute it, or just send it to everything. We have a to the power of n and b to the power of n. Here, you could, just to show you that it works either way, if we followed order of operations, 4 times 2 would be 8 to the power of 3. And then 8 to the power of 3 is 512. But let's try this a different way. Let's send this 3 to both of those inside. So we have 4 to the power of 3 and 2 to the power of 3. 4 times 4 is 16. 16 times 4 is 64. 2 times 2 times 2 is 8. And now if I go ahead and multiply 64 by 8, I do end up with 512. So I just wanted to show you with numbers that it works out the same way as long as you apply this correctly. All right, so everything in the parentheses here, that means the 4 needs to hit everything. Don't leave out the 2. Okay, it needs to hit the 2, the x, and the y. So we have 2 to the power of 4. Well, let's go ahead and simplify that completely. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. X, it's just like there's a power of 1 there if there's nothing there. So 1 times 4 is going to be x to the 4th. And then y to the 5th raised to the 4th. Well, we're going to multiply these two together and we get y to the 20th. Okay, coming down here, make sure you hit everything inside. You could also, since this is negative, you could hit everything inside and then put them all in the denominator. Or right now we can go ahead and put this whole thing in the parentheses in the denominator. So we have 1 over 3x y squared to the power of 3. This is now positive, And now we need to make sure that 3 hits everything inside of there. So 3 to the power of 3 would be 27. X raised to the power of 3 is going to be x to the power of 3. And then y squared raised to the power of 3 is going to be y to the 6th. Okay, dividing exponents with the same base. In this case, we're going to subtract the exponents, but I did put in a note here. Wherever the power is greater, that's where we put the solution. That's where the number or the variable is going to end up. And so I'll show you what I mean by that in just a moment. Let's go ahead and give these a try. Right here, we're going to subtract them. So we have a to the power of m minus n. Okay, here, if I subtract this, so if I do this just the way I did this here, and I subtract the top one by the bottom one, I'm going to do this 2 different ways. So I'm going to take this 5 minus 7 is going to give me, let's just write it out here, a negative 2. 6 and negative 2. And we do not want any negatives, so then we're going to throw this in the denominator, and then we have to square this, and we get 1 over 36. But a shortcut here, note, whenever possible, or wherever the power is greater, that's where you put the solution. If you just look at these two numbers and see that the 7 is bigger, you can create a little shortcut for yourself and go, okay, I'm going to subtract these, but I'm just going to go ahead and put the answer where the number is greater. Okay, so take the bigger number, subtract the smaller number, and then put it either in the numerator or the denominator based on which exponent is bigger. Okay, so instead of going 5 minus 7, I'm going to say 7 minus 5, but go ahead and put it down here. So I get like that, and then I square that, and I get 1 over 36. All right, right here, here's the bigger power, number 6. So I'm going to subtract 6 and 4. I'm sorry, I'm going to take 6 and subtract 4, and I get 2. And I'm going to put it on top, because that's where the bigger exponent was. Okay, looking at these, I can simplify this 3 over 6. So make sure you do that. 3 goes into the top 1 time and can go in the bottom 2 times. And now I'm going to subtract these exponents. Well, which one has the bigger exponent? The one in the denominator has 10. So I'm just going to go 10 minus 9 is 1. And then I'm going to go ahead and leave that x down here. So x to the power of 1, which I don't even need there. I'm just going to leave it just like this. Last one here, raising a quotient to a power. Quotient, remember, means to divide. So once again, we're looking for product or quotient. So multiplying or dividing, never adding or subtracting. When it's multiplying or dividing, we have to send that exponent to everything inside the parentheses. So distribute the power to everything. So a to the power of n and b to the power of n. So here I'd want to hit everything inside the parentheses. That would put power of 4 on the 3 and a power of 4 on the 5. 3 to the power of 4 is 81. And then 5 to the power of 4 is 625. And I do not believe this is reducible. I don't think anything goes into both the top and the bottom. So we'll leave our answer just like that. All right, hit everything inside. This would become x to the power of 6, and the bottom become y to the power of 10. Same here, make sure you hit everything inside. We have a to the power of 3, 4 to the power of 3. 4 times 4 is 16, and 16 times 4 is 64. Okay, that's it. I did not leave a spot for questions. That doesn't mean you can't ask any. So make sure that if you had any questions throughout here, you go ahead and jot them down on the back. So that way I can make sure I answer them in class. All right, thank you for watching.